Hello, hi. Hello, James. I see so many people joining in. Just good. Thanks for joining in. This is going to be our last event of the year, and I'm so excited to do this meetup. Finally, we pulled through all the stuff. We hosted like almost every month, so we managed to get speakers, and then we did the live streaming. So thanks for everyone. Thanks for supporting. And today, I'm going to be joined by our my colleague that he's also Devrel. So I'm going to introduce him. So Dyson is going to join me.
Hi there. Hi everyone. Hi Pradeepa. How's it going?
Hey, good. How are you?
I'm doing well. I'm really looking forward to having the holidays pretty soon. So, it's the end of the year.
Yeah. Everybody are looking towards it. You look so tired.
Oh, I was going outside today, went to
Oh,
the office, came back to my house, doing this live streaming. So
okay.
I look like tired for today, but I'm
Yeah,
okay. Yeah.
yeah. Thank you so much. Thank you so much for helping me out. Yeah. So what's up? So I'm gonna. So this is our live stream. So I'm gonna introduce our speaker. Um, and before that, we operate on a strict code of conduct. So I'm going to pop some links here. If you want to look at our even code of conduct, we value diversity and operate a strict code of conduct for the comfort of all members. So also, I'll pop in some links for privacy. So if you want to know about what we are doing, like how we are using this data, please go through those links. And without much further ado, I'm going to invite our speaker, who is also our Auth0 ambassador. So we have a program where if you're interested in IT and security, and if you like public speaking, so we do onboard ambassadors. So you'll hear more about it starting next year. So we are revamping and then we are refreshing the program. So I'm going to invite Seiji to.
Yeah. Hello,
I think-
Pradeepa. Hello, Dyson. Yeah,
Hey Seiji,
hello,
how are you
everyone.
doing?
Yeah, I'm doing well. And yeah, I think it's a pleasure for me to be invited here on your last event for this year.
Thank you so much for accepting to talk. So, what do you do? Just introduce yourself to our fellow developers who's
Yeah,
tuning.
yeah,
Yeah.
just to introduce myself. So I'm Seiji, Villafranca. So I'm actually born from the Philippines, but currently I live in the Netherlands. So I'm a senior developer here in the Netherlands, and maybe just for hobbies. Yeah, I do a lot of biking. So this is a bike country, so I love it. I love it. So also I do a lot. I play a lot of games as well, and yeah, out of work also I do a lot of speaking engagement, and actually this is also my last speaking engagement for the year, and it's been pretty a busy year for me, and I also manage my own community in the Philippines as well. That's why I use a
Nice.
lot of this streamer so we have a lot of events also. So yeah, that's what I currently do.
What community is called
um,
Philippines?
Angular Philippines.
Anguilla. Okay. So, how is Christmas there in Netherlands? Do you get snow?
Unfortunately, we don't have much snow here. I think it's about because of the global warming, but it's still cold. So it can get,
Okay.
yeah, it can get down until I think down to -2 degrees. So it's really cold. But yeah,
Okay.
even though there's no snow,
Oh,
it's still cold.
okay. Great. Yeah, I'll leave you to it. So, get on. Go ahead with your talk, and then we'll be listening back.
Yep. All right. Thank you, Padipa. Okay. Yeah. Thank you again, Pradeepa and Dyson, for inviting me for this event. And it's a pleasure for me to join you guys for this last event of Okta. And it's an honor for me to share also my knowledge as an Auth0 ambassador and a Microsoft MVP. So yeah, once again, good morning, good afternoon, or good evening, everyone. So I'm not sure where you're from, so you can also comment for where you're residing from. So as I have mentioned, I'm from the Netherlands, so it's still morning here. And yes, we will be talking about secure micro front ends. And this is one of the most interesting topics for me because right now I am currently working as a senior front end developer and leading the front end of my company. And it's really a challenge for us to make microfront and secure. And this is the topic I want to share with you guys. So these are some tips or challenges that we have encountered during our development of microfrontends. So yeah, okay. So yeah, I have introduced myself a while ago, but just another introduction from me. So before we go on to the topic, so yeah, hi, I'm Seiji. I'm a Filipino developer which is based here in the Netherlands. So I'm here for 1.5 year already. So I went here last September 2022 because of my work. So I was hired as a senior front end developer by also creating like an identity management system. So I write code, I teach people, and typical for developers, we drink a lot of coffee just to fuel up our brain. So yeah, I teach a lot of people. So just like what I'm doing right now. So I do a lot of speaking engagements locally and internationally. So I've been into a lot of conferences as a Microsoft MVP. So I'm not just talking about this security or the micro front ends. I also talk about different technologies like Microsoft products and even open source. So yeah, I do a lot of speaking engagements in my career. So yeah, sure, I am a developer. That's pretty obvious. I'm also a community leader, as I have mentioned. So I'm currently handling Angular Philippines. So it's a community based in the Philippines, and what we currently do is we organize meetups and online session talks just like this one. And yeah, I'm also a speaker. And lastly, other things that I do that I have mentioned, I am also an author. So I have already authored a book which was published last December 2022. So this is about Spring Boot and Angular. So I also do writing, like not just books, but I also do writing in blogs and short tech stuff that I can share. So yeah, that's what I do in my everyday life. Right. So yeah, before we proceed again, so I just want to share you what are the top objectives or what would be the objective of this session. So the first one is, yeah, what are micro frontends? Maybe some of you guys don't know what micro frontends are. So if I would go onto the security stuff, so it might be confusing for you. So I want to explain to you why there are micro frontends and where does it originate. So why micro frontends are existing. So we want to learn that as well. And the second one is why. So why use micro frontends? Well, in some cases, or I think in the past ways on how we build stuff or how we build applications. So we're actually using monolithic. But right now there are a lot of architectures that we are using in our development process. And this is one, and micro frontends are the one of the processes that we are using. But since I have mentioned there are a lot of architectures, there are a lot of standards that we are now using, then why we should use micro frontends in this case? And lastly, how? So how does micro frontends work and how to make it secure? So this is actually the core of our talk today. So we will discuss on how to make our micro frontend secure at the same time. What are the standards that we are using to make this micro frontend compliance with our KSP? Okay. Right. So yeah, micro frontends. So what are micro frontends? So I am not sure, guys, if you are familiar with micro frontends, but yeah, you can be interactive. You can chat in. I'm not sure in this is this YouTube channel, I guess. So yeah, you can chat there. What are micro frontends? If you are familiar with micro frontends, where does it originate and what does it really do and how does it help the development process of the application? So yeah, let's discuss about micro frontends. But first, before discussing micro frontends, so I will have also another introduction, and this is the microservices. So let's just have some history on where does micro frontends originate. So we have the term microservices. I think this is more common than what we have in micro frontends before. So microservices, or also known as micro web services, was first used by Dr. Peter Rogers in 2005. So microservices is different from micro frontend. So it's a developed architecture which is intended to solve the monolithic maintainability dilemma. So yeah, I was talking about micro frontends a while ago, but I shifted to microservices. Why? Because the concept of micro frontends, it came from actually from microservices. So before there was micro frontends, the microservices was already born. So this is the origin of the concept of micro frontends. So because of the benefit that microservices it can offer. So there are a lot of companies, or there are really big or large enterprise companies who adapted the microservice architecture. And we already know these companies, and they're already famous, and they're already successful, just like Netflix and Amazon as well. So there are the few companies who are adapting the microservice architecture in an early stage. Okay. So yeah, there's a what we call monolithic architecture, and this architecture actually works. But why does microservice existed? What does it solve? So the monolithic architecture, it's the common thing we do. So monolithic means what? So it's a big chunk of app with a single repository or code base. So just a simple diagram that we have. So that's a monolithic architecture. So we have the UI, we have the business logic, we have the data access layer in one application. So it's a big chunk. So all of our code base is just like in one repository. It's not scattered, it's not divided into several code bases. And its role, there's no single responsibility principle. So the single application is the one doing all the stuff, and it just gets the data from the database. So this is a simple diagram on how we can illustrate a monolithic architecture. So yeah, I will also share my slides later on. So I have also included some useful links that you can use, or that you can read for uh, the topics that I'm discussing. Yeah, as I have mentioned, monolithic works. We're using it. A lot of company uses this kind of architecture, this pattern. It really works, but there's a lot of issues that it introduces. So yeah, we know it's a single code base. It's a big chunk of app. It's a monolithic application. But there are a lot of issues that monolithic application introduced. So the first one is debugging. So it's really a pain in the developers for debugging a monolithic application, especially if it's an enterprise level application. Why? Because it's a single code base. It's hard for us to debug. It's hard for us to trace, or it's hard for us to find a single bug, or a single bug that is like a nail in your single code base that is very large. So debugging is one of the major issues. Number two is maintainability. So it's kind of related to debugging. So it's really hard to maintain a single code base. Then tight coupling. So there's a huge possibility that there are a lot of dependencies inside that code base. So one change of a single feature, it can actually affect another feature if there's a tight coupling inside your application. Then fourth one is deployment and restart times. So actually, if my opinion, so a lot of companies are switching to microservices and micro front ends because of this kind of issue. So if you deploy and restart one single code base, so everything will be affected. So even though it's not intention for you to be, or to down a single feature, so it will be still affected because you need to restart the single application on the server. So deployment and restart time is really an issue for a monolithic architecture. And the fifth one is less reusability. So why? Because it can be related to tight coupling. So some of the components that are involved in this monolithic, so it cannot be reused at all because it can be dependent to another component from that application. So these are just some of the issues that we can encounter in a monolithic architecture. So yeah, this is a weakness. So we have a slower development, slower release cycle because of the deployments, lack of flexibility, less scalability, and less reliability. So you can imagine how hard it is to have a monolithic issue, and it's becoming bigger and bigger. It's like you're just creating a monster, and um, you're like it's like a pet, but you don't want to pet it. So it's really hard for you to manage this kind of monolithic app. Okay. So yeah, it's a horror. So we don't want to be Sheldon at this case. So I don't want to experience that as a developer, just to find a single bug in a single monolithic issue. So yeah, I experienced this a lot in my years of career in my as a developer. So there's a lot of solutions, and these are what we call a different architecture, which is the microservice or the microfrontends. Yeah. So we have this monolithic issue. So we always have a solution for a specific problem. So yeah, this is actually related to the single responsibility principle. So I'm not sure if you're also familiar with this kind of principle, but it is kind of related on how did they create the microservice or microfrontend architecture. So as you can see in this diagram, so there are like tools. So there's a group of tools, but you need to categorize it based on its use. So we have a drill, we have a fork, spoon, and knife, and any other tools that we can see here, but they're not pretty much related, right? So you need to categorize it based on their usage, based on how a person will benefit from it. So let's categorize it to make it cleaner. So this is a single responsibility principle. So this is where the microservice and micro front end architecture came from. Okay. So yeah, the monolithic issue, and this is the solution. So I want you guys to see the visual of it. So just to be clear and not to explain a lot of stuff, but compared to the other illustration that I have shown you, so this is now the monolithic, or sorry, the microservice architecture. So from a single big chunk of app, so we are now dividing our application into different apps as well. So it's not a big chunk, but divided into separate chunks based on its usage or based on its feature. So in a microservice architecture, so we have different microservices. So we can categorize, as I have mentioned, so we can categorize it based on its use. So for example, for the user API, for the transaction API, or any other sample APIs, so you can categorize it based on how the application will use it. So they also have their own pipelines or CI/CD. So it's just like acting as a single app but connected to each other. So this is a microservice architecture. Okay, yeah. So I know you're not interested. We're not going to talk about microservice in a deeper dive because, yeah, the title of my topic is a micro frontend. So why do you care on about microservice? So let's move on to micro frontends. So I have discussed microservice because this is the history of microfrontends. So yeah, they have come up to a solution that hey, let's divide the back end into separate parts. But why can't we do it on the front end side? So let's also do it, right? So yeah, it came up in ThoughtWorks Technology Radar at the end of 2016. So microfrontends, I would say it's kind of new. Not maybe 7 years. So 2016. So it's still new, and there are a lot of emerging technologies on how we can do microfrontends. Right now, there's a lot. There's a lot of ways on how to implement it, and it's really emerging and emerging based on security, on the standards, on how we handle the states. So microfrontend is still emerging. So yeah, microservice concepts, it's going into the front end world. So the concept of microservice, it's adapted to the front end side to become a micro front end. And it's to develop a web app into a composition of features which are owned by independent teams. So that's mainly the purpose why micro front ends are developed or created. Okay. So yeah, well, the idea is not new. So it has a lot of common with self-contained systems. So even though the micro front end is a new way of architecting our application, so it has also like an inspiration from other technologies. So this is called the self-contained systems. But to make it simpler, so it's also an inspiration of using iframes. So if you have used iframes several times, so iframes is just like loading another application into another application by just loading its domain. So actually, I would say it's also a form of micro frontend, but in a less secure way. So micro frontend is just built just to make the iframes more secure and in a more standardized manner. So micro frontend is already existing from the past. So yeah. So to make things clear, I just also prepared a visual or an illustration for you. So micro frontends. So for example, we have the monolith. So in this case, the monolith is just a shop team. So it's basically a monolith architecture. So we have a single chunk of app. So the front end, the back end, and the database. Front end and back end rather are in one application. So um, when the REST API or the GraphQL have emerged, so we have separated the teams into a front and back. So we have a front end team and the back end DevOps team. So we just have the back end API, so the endpoints that will be called by the front end. So the back end is having a documentation just like Postman or Swagger, and yeah, they're only concerned for the back end part, and the front end also has its own team creating the components for the front end or the client side. Then, as the time goes by, so microservice um, has entered the industry. So right now, the backend team is also separated based on their teams, or based on the features that they are working on. So we can see on the third illustration that we have separated microservices like payment service, um, user service, something like that. So something something that we can differentiate from the backend DevOps team. So these are just microservices, but on the front end team, it's still monolithic. So this is still like a hybrid situation for this kind of architecture. So as the time goes by again, so micro front end is entering the industry or entering the architecture. So now our teams looks like this. So it's an end-to-end teams with micro front ends. So we have different teams for front ends and we have different teams for back end. So we have a team inspire, team search, team product, and team checkout. So they are divided based on the feature that they are working on. So we have both micro architecture on the front end and the back end. So this is now you can see in different companies that they are doing this in this way. So it's easier for them to manage the teams at the same time. It's a much faster and rapid development for an application. So this is the structure that you will mostly see in large companies. Okay, right. So yeah, I've already told you what are micro front ends. This is the new architecture, and this is the most used architecture or pattern for most of the enterprise or large companies. But yeah, question: why do we need to use it, or why use it compared to the monolithic architecture? Maybe I've answered this question a while ago, but yeah, let's discuss it again. So it's technology agnostic. So this is the one of the main benefits of a micro frontend. So it doesn't force you to use a specific framework. So for example, you're using Angular, you are using React or Vue. So different teams can use different frameworks. So they are not hardly dependent on other teams. If they are using Angular or React, you're supposed to use Angular React as well. So they're agnostic. So it's based on your capabilities, on based on the needs and requirements of that specific feature. Then number two is the code isolation. So yeah, as I have mentioned a while ago, one of the major problems of having a monolithic issue or a monolithic architecture rather is the debugging, the maintainability, and at the same time the tight coupling of the code. So having micro front ends, we will reduce these issues for building an application. So having a isolated code, so we will reduce the tight coupling of the components. So this will allow us to make things more reusable compared for having a monolithic architecture. And yeah, number three is the established team prefixes. So this just means that we can separate the teams based on the feature. So as I have mentioned a while ago, or as you have seen the visual that I've shown you, so we have different teams that are assigned to the features that they are working on. So yeah, uh we can easily identify what are the teams, what are the responsibility of each teams for creating or developing that specific app, right? So yeah, this is one of the major uh, advantages of having a micro front end. So each micro front end, it's like a single application, and they're not tightly coupled. They have their own life, I would say, and they have even their own pipelines and deployment pipelines and CI/CD. So even though one micro front end is down, so micro front end B or C doesn't care about micro front end A. So if it's not working, so it B and C will still work. So because they have their own source control, they have their own build and test pipeline, and they also have their production URL. So it's like just a single app that are connected to each other, but are not tightly dependent. So this is the main advantage of having micro frontends. So yeah, that's I think that's the main reason on why should we use micro frontends. And now, so how we can implement micro frontends. So as I have mentioned, technology of micro frontend is agnostic. So we don't need to rely on one specific framework in building this whole application using micro frontend. So it's really flexible in how to implement it. So we have different ways on how we can implement it. So as I have mentioned, number one is iframe. So iframe is considered as a micro frontend, but this is not the new way anymore. You can uh, use iframe just to know how the concept of micro frontend works, but I would not recommend using iframe for building a micro frontend application. And two is web components or Angular elements, but there are a lot of ways on how we can build web components right now. So just like lit, bit.dev, so there's a lot of ways on how we can create web components. And web components are framework agnostic as well. So if you have created a web component using Angular, Vue, or whatever framework that is out there, so you can still mount that component in different frameworks as well. So um, that's the main advantage of web components. Number three is Angular libraries, but not just Angular libraries. We can also create libraries using React or Vue or whatever framework you want. So these are just like web components as well, but libraries are also considered as micro frontends. Then number four is monorepos. So this is actually the emerging technology right now because of the tools that monorepos can provide for creating micro frontend. So one of the most famous micro frontend that we have, or micro frontend tools or NX monorepo tools that we have right now is NX and Lerna. So you can also search on how you can use NX in building monorepos, but to uh, simply simply discuss on what are monorepos. So monorepos are composed of different micro frontends, and you can share libraries in just a single repository. So these are the monorepos, and there's a lot of integrations with monorepos like module federation, web components as well. So it's really a great tool for creating micro frontends uh, in your application. And lastly is the customized orchestrator. So if you want to be more flexible or you really want to have a complex configuration on your micro front end, so I think orchestrators are the best or the suitable tools for you to develop a micro front end. So one of the I think the best example for having or best example for an orchestrator is using a single spa. So this is one of the tools that I've used in creating a customized orchestrator. So this can be complex, but yeah, it depends on the needs or the requirements of your application. Right. So yeah, it's like I'm selling you micro front ends. Hey, you should use always micro front ends. It's really good. It solves a lot of stuff, and it's a win-win situation if you use micro front ends. It's like that's what's coming from my mouth. But yeah, even though micro front ends are cool, they're great. They solves a lot of stuff, but it also gives complexity. So if you can imagine, building a monolithic architecture is very difficult. What else if you build a lot of applications? So it's really hard to connect this application as well. Yeah, you have different teams, but you need to be organized. You need to have a orchestrator that can handle the states in an organized way or in a right way on how we can handle or how can share data from one microfront into another. So these are one of the complexities that we can encounter. And secure microfrontends. So this is the major problems that we can encounter in building microfrontend. So it's the authentication and authorization. And this is the main topic that we will discuss. So yeah, um, if you think of authentication and authorization, one of the major things will go into our mind is the scope handling. So sometimes in our authentication, it's not just like authentication. It's not just like giving the user an access to our application, but there are different scopes or roles. So it depends on the level or the access level of the user on a specific application. So it's not just logging in as a simple user, but we have different levels. Like if you have an admin, you're just a basic member or you're an editor. So this is one of the reasons, or this is one of the factors that we need to think of in handling in our application. So yeah, based on OAuth 2.0, scopes are just like request parameters. So they are space delimited. They are just like strings that describes what are the scopes of a specific user. Yeah, for example, we have a tenant scope or a group scope. These are considered different scopes, and these are space delimited. So this is how we usually design the scopes in our application. So if we put it in the world of microfrontends, so the concept of scopes are keys. So the scopes or this space delimited strings, they are like keys in microfrontends. So they're just representing different levels of access that are tied into different client IDs. So yeah, microfrontends, they see it as a keys. So these are the main concepts of how we handle scopes on microfrontend. So how we can handle scopes or how we can handle authentication and authorization in the micro frontend. So if you will think of it, micro frontend is a very complex architecture. So you will think that how they can share the token or this client IDs as different applications are involved in just one big chunk of app. So there are actually two ways or two strategies that we can use for building this authentication and authorization in of micro frontend involvement. So the first one is the BFF implementation. So this is not best friends forever, but this is a backend for front end implementation. So this is the current architecture that we are using in our company. So this is a backend for front end. So and the second one is the front end silent login. So we will discuss this in a form of a visual or a form of illustration so you can know better what are the difference of the two implementations that we have right now. Okay. So first, the BFF or the backend for front end implementation. So just to summarize, so we generate an access token for each new request. So for every request of a micro front end, there's like an API gateway or additional layer that will request a token for every data that the micro front end will get. So to basically explain you guys on how BFF implementation works. So this is the illustration. So we have the front end host that host our orchestrator or our host application. This is the parent app that we have, which is like the parent or the container front end. Then it boots up all the children applications. Then we all have the micro front ends. So what does the micro front end do? It just gets the data. So it doesn't have to do with the request of the service scopes, but it's on the BFF application side. So BFF application is just like a backend with APIs, but it has this responsibility to validate the token authority. And at the same time, request and access and ID tokens based on the service scope. So the BFF application is the one having this responsibility. So after that kind of step or after that step, when the BFF validates it, or request for the token authority and the access and ID tokens, so it will call to another backend, which is our service for the request. So if it's validated, so it will send the response and uh, prepare the response and send the response and bring it back to the micro frontend. So in this kind of architecture, you can see that the micro frontend doesn't have that kind of much of responsibility when it comes to the authentication and authorization. So it's just like the BFF application is the one orchestrating or the one organizing the states or the tokens that the micro frontend needs. So we are placing out the responsibility from the micro frontend. So this is how the BFF implementation works. So if you will think of this BFF implementation, these are the advantages of implementing this pattern or architecture. So the number one is the strong security capabilities. Why? Because we are not exposing the BFF application in the outside world. So the BFF application handles the requesting of the service scope. So this does not really exposed on what are who is responsible for the validation of the token authority. And every time we request an API, so there's a new token generated based on the things that we need or the service scopes that the user needs on that micro front end. The second one is the granular access control. So in this advantage, so every time we request a new token, so we don't actually use a single token for us to request these service scopes that we need. So it's granular. So um, we can't use a single token just for us to use a service scopes. And lastly is the isolation of microfrontends. So we don't really need to maintain states in each microfrontends, and they can work on their own since we don't have any other responsibilities just to get and display the data. So these are the advantages of a backend for front-end implementation. And I would say that this is really secure on how we can implement micro front-end in terms of having an authentication and authorization in our application. Okay, so for you who are not really familiar on how this backend for front-end works, so this is um, the simple illustration that I have. So it's like we have two layers of API or backend APIs. So um, every platforms has its own BFF, and the BFF is the responsible for getting or validating the token authority and getting the access tokens that we need for our application. So this is like adding an additional gateway for our applications in our client side. So yeah, it's really strong. It's really secure. We have this kind of advantages that we have for this kind of architecture, but also it introduces some disadvantages in implementing this BFF or backend for frontend. So it can cause performance impact. Why? Because we issue a token every time we request a scope or we request for the client ID. So it's really a performance impact for the token issuer. Number two is the cost implications. So you are requesting every tokens that you have that you need. So it can have cost depending on the token issuer that you have. And simply the complexity because we have an additional layer of having a BFF application in our um, application. So it's complex for the developers to implement this kind of pattern. So these are the drawbacks of having this BFF implementation. Okay. Then, so in order for us to prevent that, prevent the implications or the prevent that kind of issues that we have. So one of the best or one of the main solutions for having a complexity or performance impact. So it's improving the performance that can be done by the caching strategy. So we can also apply caching for our tokens on for having the BFF implementation. So we can have we should have a cache invalidation strategy. So since we should our caching should be always be reliable if our tokens or if you want to cache our tokens. So we should apply security measures if you want to have a caching strategy, and we monitor the cache performance so our cache will surely work in terms of authenticating and authorizing our user. So this is one of the solutions if we want to improve our backend for front end implementation. Okay, so that is our backend for front end implementation. So we can see that there's a lot of drawbacks like the performance impact, the complexity, and even the cost is one are the disadvantages of this kind of implementation. So the next implementation that we have is the front end silent login implementation. So the front end silent login implementation is like the inverse of a BFF application. So instead of placing the responsibility of the service scope for the BFF, so we are now placing the responsibility to the micro frontend itself. So the token is generated once the microfrontend bootstraps, and it's used as an any other token added to the headers. So this is just like a JWT, or once the micro front end or all of the child applications are bootstrapped, so there's just like one single token that we share for us to authenticate or to authorize the user that is logging into our application. So as you can see in the diagram, so it's pretty much different on what we have on the BFF application. So it's like combining the micro front end and the BFF application. So the responsibility of the BFF for having a requesting of scope of the service access token, it's now on the micro front end. So it has a token on the request header as it gets the data on the backend side. So we can see here the request scope service access token is on the micro front end layer, and that is where it talks to the token issuer, so it validates the token authority, it issues the access and ID tokens for service scope, then um, the next steps will proceed. So that is now the pattern, or that's how the front end silent login works. So what does my front end silent login implementation resolves? So it's what this is what are the disadvantages of PFF implementation. So it improves performance as number of requests is reduced to the token issuer, since we're just using a single token. We don't need to have any tokens, other tokens every time we request a data. And at the same time, we reduce the cost, because also the call for the token issuer is not or we're not issuing a token to the token issuer several times already. So this solves that the disadvantages or the issues that the BFF implementation is introducing. But if you will think of it again, this kind of implementation has drawbacks also. It solves the implementation or the drawback or the issues that the backend for front end implementation is introducing, but yeah, it has some disadvantages also. So these are the major disadvantages of a front end silent login implementation. So the first one is the sensitive data exposure. So front end or the micro front ends needs to know the client ID of the token issuer. So it can be exploited by attackers. So for us to secure this, so the common way is to put it in the vault on the secrets. So we should not put that on the front end side as a hard coded value. So this is really critical for us. So since micro frontend has this kind of responsibility already, then it's very famous. So XSS or cross site scripting. So our token is on the front end. So any hackers or any fraud can be injecting some kind of malicious JavaScript in our front end. And if your front end is not secure and you're using this token, so it can be hacked or something. So you should restrict all the sources of scripts and other resources by using Content Security Policy or CSP. And lastly is the scope creep. So um, we are using a single token, so this can be modified, so it can be intercepted. So instead of just having the scopes that we need, so the hacker can add additional scopes that we can request. So for example, we just have an access to the email or profile, but if our token is tampered, so anything can be accessed now. So it can um, I can add some additional scopes that I don't really have an access to. So this is also a downside for this front end silent login implementation. Okay, so yeah, this is these are um, the two implementations that we have, but they also have disadvantages. What if we must or we want to bring balance on this both app implementations of uh, the back end for front end and the front end silent login. So we can actually combine the advantages of the two. So this is the balance. So one of the main solutions is server side rendering or SSR. So just to explain it in a summary, so the entire generation process is occurring on the server side. sharing only the final result within the client page. So we are now again um, moving out on giving the responsibility to the micro front ends. So micro front ends are just micro front ends. We don't really put any responsibility for that specific application or specific client side application, but everything now happens on the server. So to making it more secure and leaving it outside or not exposing it on the outside world. So it's a less involvement on the front end. So front end doesn't care anymore on how we do stuffs on the token. Okay. So yeah, SSR can help to improve security by handling the initial authentication process on the server side. So to give you an idea, so these are just how server side works. So a browser request with the session. So next.js app is a one example of a server side framework, but you can also do it with other frameworks as well. So the token happens on the backend API, so everything happens on the server. So it will just it will return the static pages already, but with the token with the scopes that you have, so everything is processed on the server. You will not see the communication of the token issuer on the front end and the back end already. So this is not exposed on the outside world. So this is SSR. But to know more about SSR, so there's a lot of documentation or there's a lot of articles on how does SSR works, because this is also a different way of implementing stuff. So for us, server side, it's basically the balance of this front end or for back end implementation and the front end silent plugin. But we also need to take care some of the stuffs that we need, or some of the stuffs in developing the application using SSR. So number one, um, we are giving the responsibility to the server. So we must secure and store and manage the user's authentication token, since the server is now the one responsible for issuing us the token. And we must ensure that the token is securely transmitted to the client and that is not exposed to potential attackers. So now we are securing the server itself already. So it's not the micro front end, but um, not the server from the micro front end, but this is the server itself where all of our apps are stored, like the backend API and the front end application. Okay. So yeah, server side rendering solves the balance, but there are still other things to consider in building an application or a micro front end application. So as a micro front end or as building different application, so we should have an organized way on communicating the data or having a synchronized data in different applications or different micro front end applications. So it's composed of different components that can run or develop and deploy independently. So managing and synchronizing the user's authentication is very critical. So in order for you to solve this is I would suggest that use state management in synchronizing this data in the micro front end applications. Then routing and URL management is also a factor. So it's a combination of states. So routing in URL is also affected by doing micro front ends, because one route can be a micro front end, another route can be a different micro front end. So there should be, or maybe in some ways, but in a lot of chances, a specific logic in each micro front end is required to receive messages um, from a single API. So we also need to consider on how we can build this routing and URL management. And sometimes you also need guards and protection for each routing based on the scopes. So this is also one of the main factors that we are considering in building applications. And yeah, these are just the state managements that we have on the front end frameworks, but there are a lot. So this is based on the Redux pattern that we are using. So in our company, we are currently using state management to handle our um, authentication or other data that are shared in different state or different micro front ends, right? So yeah, so I've discussed three implementations or three patterns for um, implementing authentication or authorization in your micro front end. So your main question is, yeah, what to choose. So what's the best for you for your application if you're trying to build a micro front end with authentication and authorization? So first is the backend for front end application. So this is, to summarize, it offers strong security and fine-grained access control. So it's secure. It has an additional layer that issues the token, but it can introduce performance and complexity issues. So front-end silent login solves that. So it simplifies the management, but raises concern about security and scope control. And it cannot be the best implementation for application that has high sensitive data, because um, this is more vulnerable compared to backend for front-end application. And lastly, the server-side rendering. So it's actually the best of both worlds. So it has a more centralized token generation process, since we reduce the number of calls to token issuer. At the same time, we are not exposing the client IDs, or we are not putting the responsibility of the issuing of tokens to the micro frontend itself. So it's like the best of both worlds for front-end silent login and back-end for front-end application. But also, it's not really the silver bullet, because still server-side rendering is another way of implementing your application or your whole application as well. And it can cause also a development time for building your application. So yeah, there's this three implementation that we have. So how do I choose between these three and implementing your app? So I just have a conclusion for this one. So it depends actually. It's based on your specific needs, constraints, and security requirements of your application. So you need to carefully study what are the requirements, what are the security measures, what are the KSPs that your application needs. So it really depends on the team, or really depends on the application that you will build or develop. So it's more of like a brainstorming on what are the stuffs that you will really need for developing this kind of app. So yeah, you should have considered the security measures. And other than that, so if you need monitoring or any usual activities, so these are the stuffs that you need to consider as well for your apps in order for you to choose the best implementation for building your own application. Right. Yeah. So requirements should be heavily considered. So that's the statement that I would say, if for you to know what is the best implementation for you. So I will not dictate what implementation for you guys um, that you will use for your application, since yeah, it really depends on every app that we build. But yeah, it also um, it's also helpful for us to have some diagrams or uh, some comparison. So, for example, for the security level that each implementation provides. So, this will be helpful for you to decide on what will be your best implementation or architecture for your authorization and authentication for the micro front end. So, yeah. Okay. So, yeah. So, that's it for the micro front end security, or for the authentication and authorization. So I will be sharing my slide to you guys. I think yeah, I will be posting it, or I think Pradeepa will be posting this one on our chat in the YouTube, I guess. So I also included some references that you may like to read. So I think I found this helpful. So the things that I have discussed, it's actually from a great blog, but we are actually using it. So I found it very good for you to present it, since these are like the common architectures that we are using, like the BFF. So in our current company, we use this a lot in different projects. So yeah, for you to read, so just read this kind of stuff. So this is not really directly related to micro frontends, but this is also related to uh, the concepts that I have discussed. So yeah, feel free to read these articles that we have. And yeah, that's it for my talk. So if you want to reach me out, yeah, I'm also a mentor. So this is my LinkedIn. I think, yeah, we will be posting my social handles. And I also have my own website, seijivillafranca.com. So if you are curious on the things that I do, other things that I write on, so it's also available there. And yeah, once again, thank you for listening to my talk. And yeah, happy developing, guys.
Thank you so much. Thanks for taking the time and amidst holiday season, and then presenting this talk. This is really informative. I find it like really useful because you covered from the beginning like why this should occur, and then what are all the things that you have to do, and then like what are all the possible traps you might look out for. So I think this will be definitely helpful. As you mentioned, if you can share the slide, so
Yeah.
I can update it in the LinkedIn description. Yeah.
Yep.
Um, yeah, I don't see any questions in the chat. So, uh, but what I would say is like, was it widely adapted, the Microfrontends, or because you mentioned it's different than microservices. So how let's say how is it being adapted in the industry? Is it yeah?
Yeah, it's actually heavily adapted, Pradeepa, because right
Okay.
now, um, yeah, especially in our companies, we are composed of different teams, and um, just like Google. So even though we build different applications, it's like we share a lot of we share common web components. So
Mm-hmm.
it's just like to reduce the boilerplate codes that we have. So for example, we have something like, yeah, just to make it simple, we have a single table that has the same functionality from one app to another. So we don't like to have a separate code for that one. So we build
Okay.
it, so that reduces a lot of boilerplate. So that's why it's now being heavily adapted. So even in my previous companies, so from a monolithic part, so how do we solve this kind of issues, like having a single pipeline? If one is down, everything is down. So we don't want that to happen. So yeah, the main solutions that we have is having a micro front end. So yeah, I would say it's heavily used in different companies now.
Okay. Great. I hope that you're writing a book again because this is like one book worth of content. I'd
Yes.
really love to read it. Thank you so much. Happy holidays. See you soon. I'll just hop on to the next segment. Yeah. Thank you so
Yep.
much.
Thank you so much, Pradeep, and happy holidays, guys.
Yeah.
And yeah, hope to have a great day again.
Thank you. Thanks, everyone. Thanks for tuning in. And that was an elaborate talk. So, this is going to live in YouTube. So, catch it when you have time, and then you can see what are all the things that you have to observe. How do you design micro frontends? If you have any questions, we dropped Seiji's LinkedIn and his website. So, you can ask him questions in the LinkedIn and ask for specific questions in the chat. Yeah, so over to the next segment is what we call as ask our identity expert. Today Carla is supposed to join us. She's our fellow devrel, and she specializes on Passkeys. She even gave a developer keynote uh, in our Okta Dev Days, which is one of our conferences, which is a developer focused conference. And unfortunately she is sick, so I have collected questions and some questions from the conferences and other from other field for the developers, and then I've compiled some questions, got the answers for you, so I'm going to start right away. So the first question which I had from the developers were, we are talking about passkeys a lot, and they are curious to know what are passkeys. So I'm going to give you a simple demo on how a passkey based authentication looks like. So this is WebAuthn or Passkeys playground. So I'm going to show a simple authentication procedure, how this looks like. Um, Give me a minute. Okay. So normally when you go to any application, you see username and password, or username, or connect with socials. So with the passkey authentication flow, this is what you see. So let's say you have to key in some name, username or password. So let's say Pradeepa Passkeys at testing.com. So I am going to show what is going to happen when you say like create like registration, like during registration. So this is your app. This is how you access the app from the browser. So it hits the server, and now it reaches my device, which is my laptop now. And then the Chrome browser now it's prompting. It says that for this username, I don't have any credentials. I can't see anything. Please create a credentials for you. So I'm going to say yes, say continue. Now the browser is asking me to create credentials for this app, like Link Party. This is the website, myapp.com. So I'm going to say use my uh, biometric, and this is what changes happens. So you see some changes are happening, exchanges are happening between these. But whenever we are passing something between the browser and the server, we are not passing any shared credentials. So that is the highlight, or that is the main point in Passkeys. So I'm going to take you to the new credential that is being created. Say this is my raw ID, can be called as a unique user ID or something. And then when I was like accessing the biometrics, so I'm creating a credential which is actually a private key and a public key that we call is key pair. So the public key would look like this. As the name suggests, the public key part of the credential can be public, can be sent over the network. There is no sensitive data available there, but there is also a private key. We call that as an asymmetric keys. So for example, let's say you send a message and then you encrypt with a private key. You can only decrypt it with a private public key. It can also work otherwise, but so you have your private key stored in your device, in your, we call that as an authenticator. And then the public key is sent to the relying party, which is the website. So let's go back. Now we have registered the credentials, right? This is like something, I have created an account in a website like myapp.com. And how do I authenticate it? So what I'm going to do is like I'm going to use my ID, which is my raw ID, and then say login. I'm not sharing any credentials now. If you click on it, so the browser sends some raw ID and challenge. So now the browser identifies that that I already have a password in this. I'm sorry. Yeah. So it doesn't prompt me to create the credentials. Say it finds something like this device for this username. There is already a credential created, and the browser is able to read that credentials via my like if I prove my presence. So I did a biometric presence. So if it's your mobile phone, you can use your PIN or your pattern to unlock it. So this is how a normal journey looks like. Um, I hope you understand how the transaction or uh, the passkeys based authentication would look like. So the first question I had was, what are passkeys and how it is different from passwords? So if you say passwords, what does it come to your mind? Like there is a secret, like your username and password, and that is sent over the network. Let's say the myapp.com website. So when you create an account, myapp.com has to store your password. They have to hash the password and store it, but you cannot completely assure that that particular account is actually hashing your password and storing it. It can store the raw password, or they can store it in a vulnerable place that the database can be like attacked, and the credentials can be leaked. So all our presence is actually based on our username and password. So if the password is stolen by someone, then someone can act on our behalf and then compromise our account. So that's the major problem of our passwords. So what are passkeys? Passkeys is nothing but it creates a key pair that what I have shown. So when you send a passkey, like when you create a credentials like a passkey, a private key is stored inside the device, and a public key is sent to the server. So for example, when you create, you will see something called challenge. So let's say, for example, I want to create the credential to myapp.com, and myapp.com will say that, this is your challenge, some random string. It will send it and then say like, you create the credential and then you sign the credentials with this, the challenge, and then send it back to me. So while sending it back, it will sign the challenge and also will send the public key. So anybody who can, when the transaction completes, the challenge can be, decrypted with the public key, and then the website can verify whether this is the person who has done it. On the other hand, in the end user, we have something called authenticator. So for example, if your laptop is biometric enabled, you can use that to create your credentials. So basically it creates a credentials and then and store it in your credential manager or iCloud keychain that can only be accessed via your biometrics. So you prove your presence and then you do it. So the knowledge based passwords are have evolved to the credentials to prove that who you are, not who what you remember. So the second question I have is, how do passkeys help with the password problems? So we need to understand what are all the problem of the passwords. If you go to haveibeenpawned.com and enter your email address, you can see how many accounts that your password has been breached. We sometimes like LinkedIn or sometimes like Box, even the popular accounts, that those are all breached. You know why? Because the those credentials can be tampered or can be guessed, or the password problem of password is because it's a shared credential. With passkeys there are no shared credentials, so you create something and you store it in your device. Nothing's exchanged over the network, so no one can compromise your device, your account. um, so what's the other problem with the passwords is like, sometimes even if you see what's the top used passwords, those passwords are very simple. For example, like abcd123, qwerty, host, guest. So many passwords that have been created and found online are easily guessable, and anybody can just use your email address and account name and then just try to brute force it and then guess your password. The second problem is with phishing. So even if you have not, you have an uncompromisable password, a fake website can look like a normal website, and then wherein you key in your data, and then that data can be captured, and then someone can compromise it. So it's phishing is another major problem with the password, stolen credentials, guessable password. With passkeys, when I mentioned that we are creating a credential, when we create a credential, we have something called um, the specific relying party. So whenever you're creating the credential, you're actually creating the credential for that particular website. For example, www.gmail.com, and then you create a credential. So if someone is trying to access the key, it will verify where this request is coming from. Say, for example, I have my credentials stored for gmail.com and some fake website is trying to access it. It will match the relying party ID, and if it doesn't match, it will not provide you access. So it's phishing resistant. So most of the password problems, or at most say like 80% of the problems, are due to phishing attacks. You can also verify the Verizon data breach report, so you can see like most common compromises happens with passwords, guessable passwords, and stolen credentials and phishing. So passkeys are phishing resistant, no shared credentials, and no exchange of private keys over the network. And that's what is helping passkeys uh, with the password problems. Um, my other question was like, for example, let's say I have a mobile and I wanted to log in to my MacBook, right? So why do I have to create how do I use it, right? um, so this is same platform, for example, iOS. So what you can do, you can sync your credentials in your cloud chain, and then your laptop which uses the same iCloud account can retrieve the credentials and then use it. You can also choose to create own credentials for your devices. So this will give you what do you call, this will give you like venues to create for a single website. You can create multiple passkeys. Those passkeys can be created by different devices. For example, let's say I wanted to create a passkey for my gmail.com using my mobile. So I can do that. So like create a passkey, register my mobile device, use my face ID recognition, and then create a passkey. In my laptop, I can use my fingerprint and then I can create a passkey. um, I'm going to go over why you have to create multiple passkeys. Um, but those are all the possible ways that you can reach it. There is something called a YubiKey, if you have heard of it. So YubiKey also can use that supports WebAuthn to capture the credentials and capable of creating the credentials. You can also store your portable key and then store your credentials and then share it. So in that case, you can actually take the UP key, it's a portable key, and then you can connect to any devices and authenticate it. You can connect your mobile phone, and there are so how do you use passkeys across platforms? For example, let's say you log in with your iOS, and then let's say you have your Windows laptop. So there are two options to it. One is like when you are logging in with the key, credentials, it will prompt you whether you want to create a passkey or you want to use an existing one. So if you have an existing one, a QR code will show up. So you can show your mobile and capture the QR code. And then if that mobile has the credentials stored, it will complete it. You can just continue the process and it will complete it. And once that the verification is complete, you will be redirected back to your application. So that's how it works. So basically, your cloud providers will sync your credentials in their own cloud chain. So that's how it works. Works across multiple platforms and multiple devices. uh, the last question I have is, what does the recovery flow look like? For example, let's say I forgot, like I say, like I have a UB key and I have lost it. How do I recover my account? The one is like if you have multiple devices, like for example mobile YubiKey, which I mentioned, like you can register multiple devices, then it will be useful for you to um, retrieve the credentials at least from one of the devices. So that's the reason why you have to register one or more devices with the passkeys. So once you have lost it, I think you have lost the entire account. The other thing is like if you go to Google accounts, you can see that they use passkeys as a second factor authentication. So what they did is like you have to prove that you are the person who you are by keying in your email ID and password. And you can have multiple options like your SMS or recovery codes, backup codes, and passkeys. So in case you lose it, there is a way to recover your authenticator, your account by other means. But if you have other devices, so you can actually remove the one if you have lost it and then register another devices. But ideally, if you don't own anything, like the password is not shared at all. So there's only way that you could have lost the authenticator. So there is no problem of forgetting the password and resetting the password, and as long as you are able to provide your biometric or a pattern to access your secured storage, you're good to go. So I don't think you will get into the problem of resetting the password or forget password as frequently as with the passwords. So that's all I have with the questions on passkeys. We do have some YouTube videos in Octadev YouTube channel. I'll pop it down it's in the same channel. I'll pop it down here. So we call that as the identity in a minute. So we talk about what are passkeys and how to use them. There is something called WebAuthn.me playground, which I showed you. So that will tell you like what are all the things that are being exchanged. I gave an overview of how the private key and public key are getting created, but it also explains how the challenge gets done, and then how the signing works, how the client and the server creates a trust by verifying the challenge, There is a debugger. You can change the algorithm and then you can play around. I'll pop it in the uh, chat after the uh, stream, so feel free to look at it. And if you have any specific questions on the passkeys, please do let me know. uh, Otherwise, I think we can wrap up. um, Thank you so much for joining. um, so we have zero index newsletter. So if you wanted to keep up to date on developer focused newsletter, if you want to keep our developer events up to date, please do sign up for our newsletter. um, if there are any events coming up, if there are any workshops running, you will get to know all our devrel, where they're going, what are all the events that they are attending, what are the workshops we are doing. All this information will be there, in addition to what are the new features we are launching and any new tutorials we have launched. You can find it. So feel free to subscribe to the newsletter. um, Thank you all for joining and being patient with me and supporting us. um, so we're planning to do the next meetup online as well, probably Jan 30. So until then, enjoy your holidays, and yeah, see you all soon. Bye.